everyone. This is part 2 of our review for Unit Test 3, and we left off with question 12 on page 4, where we are given the slope m and the y-intercept b, and we want to give our result in slope-intercept form, and we have the slope-intercept form y equals mx plus b, where we must remember that y and x define the equation, and m and b describe the characteristics. So all that we do is substitute 4 for m, so y equals, we leave the y and we leave the x, so y equals 4x, and then plus the value of b is 1, and that is in slope-intercept form. So that's all there is to that problem. Now here we want to use slope-intercept, matching it up with slope-intercept form, y equals mx plus b. We see that the slope m is 4/5, and the y-intercept b is 4. Now, the y-intercept b being equal to 4 is at the point where x is 0 and y 4. And the slope m describes the slant, and it's easiest to think of it as rise over run. So to graph the equation, first we can label the axes and plot the y-intercept b, which is x is 0, y is 4, so we're right here. And then from that point, use the concept of the slope equal to rise over run to obtain a point. So from that point, we're going to rise 4, so 1, 2, 3, 4, and run 5. So 1, 2, 3, 4, and 5. And so it looks like we're right there. Now I missed one, be right here. Okay, so that's our second point, and then we draw the line. And I'm going to label it and the one thing to note is that the vertical change, which is our rise, was 4, and our horizontal change, which is our run, was 5. Okay, so now we want to find the equation of a line with a given 2, 3, which we'll label as x1, y1. And recall that we have, and note that we want to have this special, we sometimes refer to as standard form, general form, ax plus by equals c. Begin with, given a slope and a point, we use point slope form. So there's the other equation that you need to memorize. Y minus 1 equals m times the quantity x minus x1. And we initially make our substitutions. Substitute that, 7, x1 is 2. So in this equation, remember once again, y and x define the equation, and the slope m. That's actually the equation, but now we need to obtain this special form. So the first thing to do is to just have algebra here. We'll distribute the 7, x minus 14 on the right, we copy the left. Let me first show I'm going to add 3 to both sides. And if I isolate the y, I have 7x minus 11, slope-intercept form. That is, y equals mx plus b. To obtain standard or general form, we want the x's and y's on one side. So the easiest thing to do is just subtract x from both sides. And you could show this algebraically unless I'm doing, or you could transpose 11. And then that's the desired ax plus by equaling C form. Okay, so now we want to find the equation of a line that passes through 2 points in question 15 here. And when given 2 points, the first thing we do is find the slope. And then we're going to use the point slope form to find the equation of the line. So x1, y1, x2, y2, labeled, first find our slope formula, y2 minus y1 over x1, and that gives us y2 is 6, minus y1 is 2, over x2, which is 5, minus x1, which is 3. So it gives us 4 over 2, to be 2. And now you could use either point. It doesn't matter which point we use. We've shown it in the past using both points and we get the same result. So let's say we'll just use the point 3, 2. Where we want to go now is just point slope form. So y times the quantity x, and we have y minus, keep treating this as the x1, y1 ordered pair again, and y1 is 2, equaling our slope m2, and then in parentheses the quantity x minus x1 was 3. And that's actually the equation, but again we want this special form. So we first distribute the 2 on the right hand side, minus 2 equals distributing the 2, 2x minus 6. I always like to proceed this way, where I first obtain slope-intercept form where the y is isolated, and then just mentally transposes literal on both sides. But combines in the, so we get this 2x equaling the negative 4. Okay, moving on to the next question. Here we want to determine if the ordered pairs are solutions to linear inequality. So we just substitute, treat them as xy ordered pairs, and upon substitution we have 2 times x is 1 plus y, which is 4, is less than or equal to, let me put a little question mark above that because we're testing it, right? Less than or equal to 3. So doing the arithmetic on the right, we get minus 2 plus 4, which is 2, and 2 is less than or equal to 3. That is, it's a true statement, therefore 0.14 is a solution. It's looking solution. So we're just looking to see if we get a true statement or a false statement. So let's see what we get here. So do the same thing, substitute. And again, this is the go-to equation, or inequality in this case. Minus 2 times x is 0, plus y is 7, is less than or equal to 3. Again, put a little question mark above that. And we get 7 is less than or equal to 3. That's obviously false. And so then we would conclude that 0, 7 is not a solution. Okay, now we want to graph the inequality. And you can graph it any way you like. But recall, I'm going to label the axes. Recall that we first obtain what we call the boundary line, which is replacing the inequality. So we have to graph y equals x plus 7. You could graph it any way you like. I'm just going to use a table of ordered pairs, x and y, because y, I'm going to choose x to be 0, and when x is 0, it's obvious y is 0 plus 7, or 7. So 0, 7 is a point on the boundary line. And then just pick any other value of x that you like. But you have to be careful you don't go off the grid. Just going to see. And x is 3. You don't have to do all this writing. But showing it explicitly. Again, go back boundary line equation 3 then is the value of y, which is 10. So 3, 10. Now, when we plot those points, 0, 7, which is right here, and 3, 10, which is right there, we first want to know, are we dealing with a dotted line, or a dashed line, or a solid line? And remember, if this is greater than or less than, it's dashed. And if it's greater than or equal to, or less than or equal to, line inclusion, then it's a solid line. So we graph that solid line. And then we have to test a point that's not on the line. And if you could pick it, the origin, 0, 0 is always a good test point. I'm testing this origin, substituting into the inequality, we'd have 0 is greater than or equal to 0 plus 7, and that says that 0 is greater than or equal to 7, which obviously is false. So if it were true, we would shade in that region that includes their test point, but since it's false, we shade the opposite region. So my math lab has that unique paint feature, but this is essentially the way we do it by hand. Okay, now I gave two examples of question 18 because they're both special lines. You'll get one of them, but they're special lines because they only contain one variable. First off, the boundary line or the boundary equation for 18a is y equals 5. You can think of horizontal line, slope of 0, y is 5. Here's a point, another point where y is 5, say here, however you want to graph it. Oops, before I get too excited, this is a dashed line. Because the inequality is strictly less than. So that says it's dashed or dotted. So in my math lab, make sure you pick that feature. It's actually easy because if y is less than 5, you know it's below. But if you want to test, let's say the origin 0, 0 again, then into the inequality, 0 is less than 5 is a true statement, so we shade that region. And that region that we're referring to is again the region containing the point 0, 0, which, as I mentioned moments ago, could have been obtained intuitively because we saw it was below. Alright, so now the boundary line for this one x equals -3. So if you're using the memory device, you know it's a vertical line. If x is -3, it's right here. Another point where x is -3 above or below, vertical, say there. And we know it's a solid line because of the inequality being greater than or equal to. And then again, you don't really have to formally go through the test, because if x is greater than or equal to, it must be to the right, where x is greater than those values. But if you want to test 0, 0 again, 0 would be greater than or equal to -3. This is a true statement. So then we shade that region. So everything to the right. Okay, so 2 more questions to finish off, dealing with systems of equations. First one, to determine if the ordered pair is a solution. So there's 2 parts to this question. First part, using the point 2, 1, call it xy. Substitute into L1. L1 stands for line 1. So x2 times 2 minus y, is that equal to 5? Well, 3 times 2 is 6, minus 1 is 5, and 5 equals 5, which is a true statement. So therefore, the point is on line 1, and now test it for line 2. And again, substitute now into line 2. X is 2, plus 3 times y is 1. Is that equal to 5? And we get 2 plus 3, which is 5, is equal to 5. So that's a true statement. So therefore, the point is on L2. So since it's on both lines, then we say the ordered pair 2, 1 is a solution to the system. Okay, so now we'll do the same thing for the point 4, 7. So call it xy. Substitute into L1. So again, the equation 3x minus y equals 5. So 3 times x is 4, minus y is 7. Is that equal to 5? On the left, we get 12 minus 7, which is 5. That equals 5, so we get a true statement. So point is on line 1. And for line 2, go to the line 2 equation. X plus 3y is 5. So we have 4 plus 3, y is 7. Is that equal to 5? So again, a little question mark because we're just testing. And we get 4 plus 21, which is 25. Obviously not equal to 5. So that's false. And the point not on 2. It has to be on to be the system, even though it's a 1, then we can 4, 7 is not a solution, just abbreviate that, to the system. Okay, so final question, solve graphically. You can graph these any way you like. First, let's consider L1, which is 3x plus y equals 7. And I think what I'm going to do here is obtain slope-intercept form, transpose the 3x, so y equals negative 3x plus 7. So m is 3, b is 7. And I'll plot b, which is 7. Oh, I misspoke, m is negative 3. And then the rise would be negative 3, the run would be 1. Let's get a couple points. Rise, negative down 3, run 1. You do it again, 1, 2, down 3, 1, run 1. Okay, so we got a bunch of points. Again, if you want to do slope-intercept, or create a table of values with 1, so use any method you like to graph the line. For L2, y equals 4x. Let me do a little table. Pick x is 0. By inspection, y is 0. And because we're plugging a 0 for x is 1, let's say. Y would be 4 times 1, or 4. So plotting those points, 0, 0, 1, and 4. Looks like that's the same point, so it looks like we got a winner. So there's L2. We're looking for a point of intersection, which is obviously the point 1, 4. So our common solution is the point 1, 4. Okay, so hopefully you enjoyed that review, and good luck on the unit test. And as always, please let me know if you have questions or concerns.